Hello, this is Unit 5, Day 2. We're looking at operations and inverses of radical functions. All right, so we've done some operations before with linear functions. We're going to do them now with radical or exponential. All right, so you're taking f of x and g of x in this first one. What this means here, so f plus g of x, that's the same thing as f of x plus g of x. All right, so we take 2x to the 1/2 plus negative 6x to the 1/3. You could rewrite that as 2x to the 1/2 minus 6x to the 1/3. Okay, so now what a lot of people want to do here is combine these x's. But you can't because you're subtracting. Okay, we can't combine this anymore. Okay, there's no way to simplify this any further. Okay. So this is as simplified as this gets. So when you're adding or subtracting, you don't have similar bases here. Or you have a similar base, but you don't have similar exponents. Okay, so we can't add those together. All right, go ahead and try number 2. All right, so the same idea. The only difference here is you need to distribute this negative. Make sure you get positive 6x to the 1/3. All right, that's addition and subtraction. Let's look at multiplying and dividing. So a lot of this is kind of building off of what we did in the previous part of the unit in 5a. So you've got to make sure you remember your rules of exponents. Okay? So this is f times g of x. This is multiplication. Not to be confused with composition. All right, so again, this is the same as saying f of x times g of x. Say take f of x and get 3x to the 4/3 times x to the 2/3 Okay, we can rearrange this. I know I put parentheses, but you can rearrange this so you get 3x to the 4/3 times x to the 2/3. So what do you do when you're multiplying variables of the same base? What do you do with those exponents? We add those, okay? So the nice thing is with this one, we already have a common denominator. So this is still 3. These exponents have nothing to do with this 3. 4/3 plus 2/3 is 6/3. You should always reduce that, so you get 3x squared. Okay? Go ahead and try number 4. All right, so when you're dividing, you subtract. Okay? Nothing happens to these x's. A lot of people want to cancel these x's out. Okay? When you subtract these exponents, you are dividing. You don't have to divide twice. Okay? And nothing happens to this 3, so this is as simplified as we get. Okay? So again, apply the operation and simplify. Okay? All right, so we've talked about inverse functions before, but just to bring up this definition again. So if the domain of a function is the same as the range of its inverse, remember this means inverse. If I can annotate this, this is the inverse of f. That looks like off, sorry about that. Inverse of f. Okay. All right, so this is saying if this is true here, then the function is 1-to-1. We just want to mention that. We're not necessarily going to test you on it. We just want to make sure you hear the phrase 1-to-1, understand it's related to inverses. Okay, if a function is one-to-one, then its inverse is also a function. Kind of like we saw with x squared, f of x is x squared. When we took the inverse of that, we had to restrict the domain to get this. Okay, these are not one-to-one. Okay. Okay, because we had to restrict the domain. When we did the inverse of x cubed, and we got the inverse of cube root of x, these are one-to-one. The domain of x cubed is the same as the range of cube root of x, and we didn't have to restrict anything. Okay, so this one's one-to-one. That's what we mean by that. Okay, so go back and look at your day one notes if you're not quite sure what I'm talking about with that. Go back and look how we found, especially this one. Look how we found that inverse. Okay, so let's do a little bit with that. So find the inverses algebraically. Again, we've done this before, just to practice. All right, so we can rewrite g of x as y, and we still get square root of x minus 3. Be careful how you write your radicals, especially when you're finding inverses, because you could really mess up a problem if you put the radical over the wrong value, or if you don't put the radical around a value. All right, so then we switch x and y. So we get x equals the square root of y minus 3. Now we want to solve for y, get y by itself. So I've got the square root of y equals x plus 3. I moved some things around there. So I added 3 to both sides, and then I just flipped the equation. Okay? So we want this to equal y, so we're going to square both sides. You got to be really careful with this. You're squaring the whole side. All right? And this does not mean x squared plus 9. You have to FOIL that now. So you get y equals x squared plus 6x plus 9. All right, now the tricky thing with radicals or square roots, you get this x squared here, so now you're like, well, now it's a parabola again. That's not going to be the inverse of this square root. So we need to restrict the domain here. All right, so the domain of this function is 0. All it did was shift down, right? So x can be 0 to infinity. The range is negative 3 to positive infinity. All we do is shift it down. Okay? So remember, for it to be an inverse, the domain of the function has to be the range of the inverse, and the range of the function has to be the domain of the inverse. So we have to make this range the domain of the inverse. So we need to say that we're restricting this domain to x must be greater than or equal to negative 3. Okay. All right, go ahead and try number 8. All right, so cube roots and cubics, not as complicated as the square root. We don't have to restrict anything. They have the same domain and range for either. So not as complicated for this. So you get y. Technically, you'd say f inverse of x equals cube root of x minus 1. We should do the same thing over here. Instead of y, you'd say f inverse of x. That's the proper terminology and notation. All right, so you're just finding the inverses. Now, let's go back and do composition to prove that they're inverses. Okay, so again, what all of this means up here, remember, composition is when you take one function and put it inside of another. So this first one, this means f inverse of f of x. So I take f of x and put inside of the inverse wherever I see an x. So that's the first one. So I write f of x first, so I don't think it can be on the inside. I do x cubed plus 3. And I put that wherever I see an x in f inverse. Okay? So cube root of x cubed plus 3 minus 3. Simplify. Let's write that over here, give us some more room. Cube root x minus 3, excuse me, x cubed plus 3 minus 3. So cube root, simplify. Plus 3 minus 3 is 0. We're left with x cubed. Cube root of x cubed is x. Remember, when we're doing composition to prove that they're inverses, both of these operations need to reduce to x. That's what this notation means. Okay, so now let's do the other way. So now we have to show that f of f inverse of x equals x. So I start with f inverse. I've got cube root x minus 3. I put that inside of f of x and simplify. All right, well, the cube of any cube root is just whatever's on the inside. Okay, so it's just x minus 3 plus 3. This equals 0. This reduces to x. You have to show it from both ways. Composition is not multiplication. Okay, so this is proving that two functions are inverses using composition. Using composition is the skill. Just doing the inverse isn't what we're looking for. We'll test that separately. We want you to use composition to show that it's an inverse. All right, so we have a graph. Let's find the inverse. We've done this before. I did it a little bit last time in the notes. So you've got to find some key points here. Take those points, switch them. So we're looking at -3, -3. We're looking at -2 and -1, and then the point 1, 1. So if you switch x and y, well, this is a little bit tricky because these are now kind of the same. So this middle point is going to help us the most. All right, so if this is f inverse. Excuse me, this is supposed to be g. G and G. All right, so -1, -2 is here. So it's really just going to change the shape. All right, so notice how we just got one side of this. When we did this algebraically on the previous page, when we did the inverse of a square root, we got that whole parabola, right? Well, when you do it graphically, it's going to be more accurate, okay? You only get half of that parabola. So that's why we restricted that domain algebraically. All right, so the domain of G is -3 to infinity. The range of G is also -3 to infinity. So this works out kind of nicely for you guys that have trouble with this. So the domain, oops, that's not right. Domain goes to the range of the inverse, and the range of a function is the same as the range, excuse me, the domain of the inverse. So okay, is the inverse a function? Well, it passes a vertical line test. Okay, so yes. Okay, that's all you need to do. If you graph the inverse, passes a vertical line test, the inverse is a function. All right, so reminder, quiz next class on just graphing. Okay, and then you'll get the classwork on this material. All right, we'll see you then.